So what I want to do is I want to talk about real quick, because in chemistry you're going to run into two very, very, very important items, elements. You're going to run into hydrogen a lot, and you're going to run into basically its favorite thing to be with, H2O. You're going to run into hydrogen and water, and especially when it comes to acids and bases, water is extremely important. And so this whole thing started with a revelation by scientists that water could self-ionize. Self-ionize. Remember, the term ionize literally just means to break up into its ions. Break up into its ions. Okay? So also cat and an, right? Cation and anion. So self-ionization, otherwise known in chemistry as, my alarm's going off, so let me get that. Stop that. Otherwise known in chemistry as the ionization of water. And this kind of kicked off acids and bases. And so you have this auto-ionization of water. And let me show you how this works. So you have 2H2O. And water by itself it's going to have an equilibrium reaction. Remember this, the title for, or the symbol for equilibrium. Water itself is going to equally back and forth break up into its ions. So it'll break up into, it'll produce H3O plus, or it'll produce its H ions, let's say H plus, and then plus OH. Boom. So this is a back and forth reaction that water naturally participates in. This makes water a wonderful universal solvent. Okay, and it also makes it amphoteric, which means that it could be an acid or a base. And that means a whole lot, because when we're talking about acids and bases, we are basically talking about the let me make this very clear here. We're talking about the concentration of hydrogen, specifically with Arrhenius and Bronsted-Lowry. We're talking about the concentration of hydrogen and the concentration of hydroxide. This could also be written H3O plus, and that's going to be hydronium and hydroxide. Now, what I want to say about that, as far as getting into acids and bases, is when they seen that, then they recognized this. They recognized that the concentration of hydrogen was 10 to the negative 7th. Okay? And so when they started to get into acids, they came up with pH, right? And so they started to talk about the power of hydrogen. And so they said that the way you'd figure out the concentration, or the pH, is that you would take the negative log pH of the hydronium ion. And then if you wanted to figure out the concentration of H plus, then you would take the 10 to the negative pH. Okay, And so that kind of leads us self-ionization or auto-ionization of water. It leads us right into our acid conversation. And remember, your acids and bases, really, for the Arrhenius definition and the Bronsted-Lowry definition, kind of depend upon water. You'll see a little bit difference in Bronsted-Lowry, but it's the same general concept. So that is the brief conversation of the self-ionization or auto-ionization of water. Just remember this. This happens naturally. So it makes water a great universal solvent, makes it amphoteric, which means it could be an acid or a base. And you're dealing with concentrations of hydrogen and hydronium or hydroxide. And that led to the conversation of pH. And pH is how much hydrogen is in a solution. How much, this is like broke down into like simple redneck conversation. How much hydrogen is in solution? How much hydrogen in solution? Okay, so that's the self-ionization of water, and we'll come back and discuss Arrhenius acids and bases.